ওই স্ট্রিমিংটা চালু করে দিলাম। হ্যালো,
স্ক্রিন শেয়ারিংটা এখন ডিসেবল আছে।
ও আচ্ছা, দেখছি। দেখুন দেখুন তো স্যার। হ্যালো,
হ্যাঁ এখন ঠিক আছে।
হ্যাঁ হ্যাঁ স্যার, ঠিক আছে। হ্যাঁ, যাচ্ছি। Almost it is the right time to start our program.
Yeah.
And we got a very able speaker. This time he will be addressing both the sessions. Mr. Oshanendu Mondal, I already told you that he had a very long innings in ONGC and followed by lot of abroad assignments, and now he has been switched over to our academic community group. So this is a very unique combination what we are getting with Professor Mr. Oshanendu Mondal, or would be professor. So let us hand over the mic to Mr. Mondal. If you have any doubts, please clarify your doubts. You can ask any questions, because since the number of participants are less, now many of them have not joined till now. So those have joined, they can clarify their doubts for a few minutes before starting the today's lecture. Okay. So please carry on.
Yeah. Okay. Thank you, Amiji, once again. It's good afternoon to all of you, the participants who have already joined. We expect, I think, some more participants to join later on. Those who have joined, I think, what is the number? Around 11 only. Okay. Now, you have seen today's first topic which I am going to cover. It is water injection for the reservoir pressure maintenance. So it is also related to upstream oil and gas production. And Friday I had explained on two topics. One was with the basics for oil and gas exploration and production, and second was more concentration for deep water field. Now this particular topic, today's topic, also will be related to that only. So if any question, as Morris said, that if you have any question now you would like to ask, you can right now. If you do not come forward, then I'll have to ask someone to ask me a question. Okay, maybe that is better, because otherwise you may be thinking others will ask, I am not to ask. Okay, so the name what I am first getting, Abrojit Saha. Abrojit, are you there? Abrojit? Yeah, can you ask a question maybe related to this or anything else? Abhijit, you are audible. No, your voice is not coming. No, your voice is not coming. Am I audible? Can anybody say?
Yes, sir.
Okay, I am audible. And the slide also is visible, right?
Yes, sir.
Okay. Do you have any question? The participant who just raised a voice.
Sir, can you mention some offshore location in India? ONGC offshore location.
Okay, okay. ONGC offshore mainly in one location, mainly. Of course, there are some more locations I'll name also. Mainly in one location in a sense, which produces 60% of our indigenous production. That is known as Mumbai High. Earlier it was named as Bombay High. That field was identified or discovered, you can say, in 1974. And as you know, the development of any offshore project takes 4 or 5 years time finally to get it executed. So from 78 onwards, we have started taking oil and gas production from that field in a very small quantum in the beginning. And from 1980 onwards, we got commercial production in a very big way. So that Mumbai High is around 170 kilometers from Mumbai city. So there is a helicopter which goes to Mumbai High field from Juhu Helibase. That Helibase is close to airport also. That is not adjacent. There is a almost 1 kilometer apart in between railway line, roads and all those things. Houses are there, but almost in the same area. And that Bombay High has got 3 major locations. Mumbai offshore has got one is called Bombay High or Mumbai High. That is again from the production point of view around 70 to 80% of the total contribution from Mumbai High. From Mumbai High, that is the Mumbai offshore, one of the important location. Second is Hira and Nilam field, that is called satellite field. That is little closer to Bombay, maybe around 80 kilometers. And one more location is there called South Basin, that is around 65 to 70 kilometers from Bombay. That is mainly gas field. That gas field is sour gas and it goes to Hazira for further distribution. And the other 2 fields, that is Hira Nilam and Bombay High or Mumbai High, that comes to Uran. Uran is very close to Mumbai city. So from there, further distributions are happening for oil and gas. This is the main offshore, as I said, of ONGC. Second is now it is very famous, Krishna Godavari, that is deep water field. In fact, there are some low depth offshore platforms also, which is owned by Kane Energy, that is at the Rawa field, and also of ONGC earlier. And now the deep water, which is also adjacent to that, that is from Reliance and ONGC. So that is around 60 kilometers, within 60 kilometers from Kakinada port, which is in Andhra Pradesh. And these are the 2 major, you can say in that way. And small availability there at Kakinada, at Karaikal, that is in Tamil Nadu, that is down of Tamil Nadu. And there you will find some offshore activity, but that quantum is very less. These are the offshore fields, okay? Is it clear?
Yes, sir.
Any other question?
So there is also an onshore field in West Bengal recently, that is Ashoknagar. Is it true?
Yeah, it's true. It has already started being commercialized because the oil which we could extracted from that location was taken to even Haldia refinery also for processing to check the whether that crude is okay for refinery processing or not. That has been true also. And now this field has just 1.5 years back, it has come into our fruitful result. So the commercialization will gradually take place. As we had already explained that first the appraisal well is to be drilled, then the exploration, and then the drilling for production. So this drilling for production activity is on the way right now. And this time we'll have to develop totally oil and gas separation facility also, that processing facility also. So this will take little time. And one more thing is that if gas is there, so we'll have to get that gas to be sold to any buyer also, because the nearby consumers also have to be there for taking the gas. Oil can be transported through road tankers till pipeline is coming to the refinery, but gas otherwise you have to flare. So that's why those things are being taken up. And what I understand that as this field is now small in size, the government is thinking that whether it can be given to some private or other entrepreneurs also for further developing. But it is true that oil and gas is found in Ashok Nagar, and that will be commercialized. Okay. And Ashok Nagar is just 35 kilometers away from Kolkata airport. Clear?
Okay, sir.
Sir, I have one question, sir. Hello.
Yeah.
Sir, these company all are thinking about refinery oil production. So what about the industrial pollution? Like these companies, are they thinking about the carbon capture technology, carbon sequestration? How they control pollution?
In our today we will be covering two lectures. One is this one, you can see water injection for reservoir pressure maintenance. The other one will be for enhanced oil recovery from mature fields. And one of the technique is we can inject gas for taking more production. So there, instead of using hydrocarbon gas to be injected and taking more production, CO2 also can be injected. So that we will explain there. And CO2 can be sequestrated by that way. But all those things need a lot of investment for that, because it's not that carbon dioxide will not be available. It can be made available from the nearby flue gas being emission from thermal power plant also, because in Canada and in North America, it's going in a very big way. But in India, we'll have to see because it needs a lot of investment. So, but it is not from the refinery or oil and gas industry to go for carbon dioxide emission. It is going from mainly power plants. So it's not a worry for the refinery or oil and gas producers. It's a worry for other industry, basically how they do address to this CO2 pollution. Okay.
Okay, thank you, sir.
I think we can start today, because we'll have to complete both the sessions by 6 p.m. Okay. So we are starting right now, right? Is there any other question, or should we start? Okay, then I am starting. Okay.
Yes, sir.
Yeah. See, on Friday, what we had discussed basically two aspects, that is the oil and gas basic, means how we can find oil and gas under the earth and how we produce them. And we had also concentrated for deep water. Okay. Now today, what it says basically, this is what we have learned, that this part, right side part, that this is the well and this is the bottom, and this is the production coming from the rock, and this is coming out. This part we have learned. Now we will be learning this part. Okay. So what the total explanation will happen. First we'll introduce the topic, then we'll also clarify why the pressure falls in a reservoir, and if it falls, then what are the impacts, what it creates, basically the problem what we face, and then is it really required to do the pressure maintenance, and if it is, then how to achieve pressure maintenance, then whether only water can do or some other things also can be used for injected. So why water, as we have told in our topic, so we'll emphasize on that, and then we'll have the detailed description on water injection, and as a case study we'll talk about offshore water injection and finally conclude. See, the water injection method used in oil production is where water is injected back into the reservoir to increase the formation pressure and stimulate production. So this one sentence is very clear. What it is saying, that water injection method is used in oil production where water is injected back into the reservoir. Means along with the production we can get water, but we'll have to put that water back into this reservoir. This is a reservoir where gas, oil and water remains. So we'll have to put that water back into that so that it stimulates the production and it increases the pressure. Why the pressure falls actually? The pressure falls because in this also you can see this is covered by cap rock. Cap rock means impermeable rock, means nothing can go out of this. Okay, whatever is there inside this formation, they cannot go out. So now if that cap rock contains this much of oil, this much of gas, this much of water, for example, then if some quantity is being taken through this well, then what will happen? Some quantity will be availability of some quantity will get reduced. Obviously, the pressure will then go down. So the petroleum reservoir of oil and gas reservoir is a subsurface pool of hydrocarbons contained in a porous and fractured rock formation, and reservoir pressure falls due to withdrawal of fluid and creation of void space. So as voidage got created, so that's why the pressure falls. Now what will happen if the pressure falls? First of all, the driving force will go down. Means what happens? You see in this production scenario, how the production is coming to the top because of the pressure gradient here. This is the formation pressure and this is the well hydrostatic head. This is the well's hydrostatic head. So as the hydrostatic head pressure is less than this, so it comes inside. So now what will happen? That driving force will go down. And obviously if the driving force goes down, then the production will go down. So oil production goes down with time because of more and more production being coming out from the same reservoir. And when it happens, then the liquid which contains the gas absorbed in it, that gets dissociated or evolved out. So the gas quantum will go up. This is called GOR, gas oil ratio. So the gas quantum will go up, oil production will go down from any reservoir with time. And because of this happening, viscosity increases. Means oil's viscosity, as the gas quantum is less now, the viscosity will increase. So the mobility will reduce. So the oil which comes from the distant locations to this well, that will go down. Secondly, mobility of gas is higher than oil. Again, whatever gas is there, at that gas gets evolved, then that will go fast compared to the remaining oil. And evolved gas migrates to the crested area, results in gas cut. This is called high GOR or gas oil ratio. So that means there is a requirement to maintain the pressure, because if we maintain the pressure, then the depletion drive, that is the pressure gradient, will be reduced. So pressure support of the reservoir, also known as voidage replacement, replacing the natural displacing forces with more efficient displacing force. Now, if we go for water injection, other than the pressure is being built up, another good thing is happening, that whatever oil and gas which are away from this well, that will be now displaced by this water. This water will displace them, means force them to come closer to this well. So there are two benefits we are getting by putting water. One is the pressure maintenance, means pressure is being built up, and secondly the displacement, that means water will displace the oil in front of it. How to achieve this pressure maintenance? The pressure maintenance is possible by injecting water, gas, or any other miscible fluid from surface to the reservoir. So it's not only water, we can use gas or any other miscible fluid also for maintaining the pressure. And ways to maintain reservoir pressure is selected based on economic indicators and the development of geological conditions. Now, whether we will utilize water or CO2, as someone is asking in the beginning also, can CO2 be sequestrated? All those things will be depending. They are all possible and give the result, almost similar result. But only thing is economic indicators are main factors to select. Why water for injection? Because it is cheapest, that we can understand. Even CO2 is free. Even CO2 is maybe freely available from flue gas, but to get it transported to the locations and other processing requirement for making it 99% CO2 or so. So that will be definitely a costly scenario. So that is there. Abundance, of course, water is very much available everywhere. Coexistence with crude oil in reservoir. This is one of the important part now technically, because any oil well contains some water. So if this water gets mixed with that, so it automatically gets compatible. So it's that way have the good property to take care of the displacement of oil from water injection oil, and largely compatible. Less treatment is required to make it compatible and injectionable. So definitely we'll go into discussion of what are the treatment facility and steps to be followed. We'll find that treatment procedures are very simple and not complicated at all, and having less problem in disposal while return from reservoir. And if that water comes back along with the production, we can easily dispose them. Means either we can use them for further injecting into the well itself, or even after treatment we can dispose them for surface disposal. Water has a tendency to enter even the smallest pore of the rock, and hence is very effective to displace oil from there. So this is another technical benefit what we can find for water. Now, what are the considerations for water injection? One is formation type. If we are to really go for water injection here, so what are the things to be understood and verified and examined? One is formation type. What sort of formation it is? Because it has to be anticline. Otherwise, that the aquifer, that water which is below, that has to match with this water what we said. So that's why the formation type is very important. Formation quality, whether sand and clay contents and water there, quantum, because porosity and permeability, they are all connected with the sand structure. Formation depth, how much depth is also there, because more depth water will be always better, because it does not have much complications, and water can be pressurized very easily also because it is incompressible fluid compared to gaseous. So the formation depth also is very important. Formation fracture pressure is another thing, because when we will inject water, whether it creates the fracturization outside the rock or not. If it does so, then definitely that is again a problem. So we will have to see what is the fracture pressure for that sort of rock. Fracture pressure of overlying and underlying formation. So it is not that only there we will have to see, we will have to concentrate above and bottom of that reservoir also, because if any short circuit is there or channeling is there, it will create some problems in the overlying and underlying rocks. Compatibility with formation fluids and formation fluid properties, that is viscosity. So these are the basic criteria for water injection as far as the reservoir is concerned. But now practical considerations. Practically, what are the things to be considered? Completion of injection wells means we will have to drill an injection well which will be okay for water injection. Sourcing of water, from where we can source it, whether in nearby water source is there or not. Quantity, quality and reliability of water supply. Water treatment and pumping equipment. Laying of pipelines from pumping station to injection wells. Maintenance and operation of water injection wells. Maintenance of pipelines and monitoring of aerial sweep using tracers. So these are all very important practically if we have to go for water injection. Means we will have to go for wells, we will have to find out the source of water, what are the treatments required, whether it is possible easily or not. And finally, we'll have to use the tracers, means some isotopes will be used to see that whether really the sweeping is real sweeping, means both upward and down, or upward and horizontal movements of water is happening or not. That we need to monitor through tracers. So what sort of patterns are usually followed in case of water injection? You see, this is called peripheral flooding. Peripheral means all the well producers are inside and all the injectors are being drilled outside in the periphery. So suppose this is a cap rock, and in between production oil and cap rock, we will have to go for all injectors. So that is one type. This is called peripheral flooding. It is required in case of high viscosity, higher formation deep, dome type structure, and wells along oil and water contact. Means if the wells are, because in the formation, you see, this is water, this is gas, and this is, sorry, this is water, this is oil, and this is gas. Now the perforation can happen here, perforation can happen here. If the perforation is here, means water and oil contact, then it is very useful. Because in case the perforation is here, the compatibility will not happen because it is gas and it is oil. So those things are to be seen, that wells along oil and water contact. Then there is another type of flooding which is called central line flooding. Means whenever the producers, these small circles are all producers. Wherever the producers are, they are scatteredly available in any producing area. So there the water injection wells also will be in between in a particular pattern, and they will be almost in the central line. Means the line across which the water injection wells are there, you will find the oil production wells in both the sides. Here you will find only one side. Here you will be found in both the sides. So that's why it is called central line flooding. And this is better for low formation deep, less heterogeneous, no fractures, and wells along central position of oil field. Now, in case of pattern flooding, again there are few types. One is called line pattern. This is line pattern, means the wells, injection wells and producer wells are in lines, same single line. And otherwise 5-spot pattern, 7-spot pattern, 9-spot pattern, and 4-spot pattern. 5-spot pattern, you see, this is like a diamond. These are all, this is a producer, these are all injection wells. So everywhere you see, so 5 wells in a, there is a combination of 5 wells, 4 injectors and 1 producer. Now we can go for 7-spot also. This is like hexagonal. So where the producer and surrounded by injection wells. 9-spot also. 9-spot means you take a square like this. So there will be 3, 3, 3 and 1. So 1 oil well and 9 injection wells. And 4-spot also it can happen. It is like triangle. It is like triangle. 3 corners are water injection, 1 is oil producers. So that means practically what we find in the reservoir after drilling, we will find that there is a well which is oil producer, and there are many water injection wells surrounding that oil well. And in that way, the movement of oil water will take place at the bottom. And what is the ratio of injection to production well in case of each sort of pattern? For line, 1:1. For 5-spot, 1:1. Although I said in case of 5-spot, you said 1 is surrounded by 4. But here, if you take that, these 4 again taking one of the earlier combination. So if you take a bigger area, you will find that the number of injection wells and number of oil production wells are same. That is 1:1. In the same fashion, this is the ratio: 7-spot 2:1, 9-spot 3:1, and 4-spot 1:1. So this pattern says that in case we have started or we are going to start water injection very late, means after removal of lot of oil and water and gas from the oil well, then there is a more voidage already created. So we will have to have more injection rate at that time. So that time we will have to go for 7-spot or 9-spot, obviously, because that will only allow you to give more water injection compared to the oil production. And they are all internal characteristics basically. You see, the flooding pattern influences aerial sweep. Aerial means horizontal and vertical, area wise you can say. That sweeping efficiency. Sweeping means just to push the oil by water. Mobility ratio, that oil also moves and water also moves. Their mobility ratio and pressure distribution. These things happens because of these combinations, and ultimately it will give the benefit or it will have bad impacts also. You can say other way, that desired oil production rate, proper water injection, maximization of oil recovery, take advantage of known reservoir, non-universe, all those things basically. There are many criteria. We will not go into details. Only just try to know now that there are many impacts also happening by choosing of the pattern. So those things are to be considered while we will go for actual planning of water injection in any oil producing field. And finally, of course, the economics, because whatever we design, everything comes through some cost also. And final clearance, although technically some alternatives will happen, but economics will be the ultimate to select the single one. And if we are to go for sources of injection water, then the formation water, which is coming along with the oil, definitely that is also a source. Seawater is another source, and fresh water we can take from river or pond also. This, or even groundwater also after drilling. These are the three sources of water which can be used for injection. Formation water is best, we can say, because it is coming from the same resource and it will have a lot of better compatibility. Seawater is costlier than formation water because of its processing requirements, that is lifting, filtration, deoxygenation, chemical treatments, etc. Seawater, although it is abundant, but it needs a lot of processing treatment facility. So that's why the cost will be more compared to formation water. And fresh water is sensitive to clays. Actually, fresh water is also good, but some sources of fresh water gives the clay soiling also. Means the rock, when they come in touch with the new water or fresh water, that soiling may happen. So if that happens, then permeability will go down. Means the channels passage or all those things will go down. So that is a bad impact of fresh water, which cannot be basically addressed by any processing facility. So that's why we will have to see whether that particular clay or the stone will have any impact by fresh water or not. Availability of water source is often considered as the major dictating factor for its practical implementation. Although we say there are some technical aspect as well as economical aspect, but obviously availability will be the dominant here. Then what are the characteristics? That it should not contain any suspended solid. Means whenever we will use any water for injection, it should not have any suspended solids because it will choke the pores. It should not have any dissolved oxygen or CO2 or H2S because it will create corrosion. It should not have algae, bacteria, etc. because then that bacterial growth will happen and microbiological formations will take place. So that can also plug the wellbore as well as it can choke the pores also. The barium, strontium, iron, calcium, etc. those things should not be there because they can create a scaling across the pipeline. So that's why we will have to see that the injection water which will be used, whether they should have these things or not. In case these things are there, they are to be addressed properly. It can have a closed system, means suppose this is the production water without taking it into the atmosphere, we will again do some processing, rather pumping, and we'll put it back. So this is a closed system. Or we can go for open system, means whenever this quantity is less, we'll take some water from open source and put it here and then inject it. Okay, so this is the water from outside source, this is the open system. And semi-closed system means we'll have both open as well as closed. So this is closed and this is open. So if we go combination of this, it comes under semi-closed operation. As I said, this injection water needs treatment because it should avoid the plugging means the choke should not be plugged. It should avoid the corrosion of the pipings, because if the pipings are corroded, then their rusts and all those materials also will choke bottom side, other than leakage from the tubing also. And avoid soiling of cells, means that clay soiling also or cell soiling should not happen. These are the process which happens in the reservoir. So we will have to treat the water before injection to take care of these aspects. And plugging, in case if happens, suppose this is the plugging if it happens. So what is happening? The passage is choked. The passage is choked. So that's why we will have to avoid it. And who does plugging? Suspended solid, as I said, corrosion and bacteria, and precipitation due to incompatibility of waters, or even from the scaling materials also. This is the corrosion. You see the pipeline inside can be corroded in case the water is having CO2, H2S, or oxygen also, dissolved oxygen also. So these are the things we need to be removed before the water is being put. Otherwise, these corrosions can take place, and finally they can also choke the pores. And soiling of cells, as we explained, that in case that fresh water or water which is conducive for creating the soiling of the cell or the clay materials, that needs to be treated. And because soiling results reduction of rock permeability, because if it soiled, then definitely the permeability will get reduced. So the best treatment for this is injection of HCl into formation for several hours before the start of water injection. In case we find that this fresh water is conducive for soiling, then what we should do? We should put some HCl, hydrochloric acid, and close the well for some days. Then they will be seasoned up, so that any water, fresh water which otherwise could have created the soiling, that will not happen. So as we have to take care of these aspects basically, so that means what are the intention to do the processing? One is called sedimentation, means to settle out the sediments, means whatever suspended solids are there, that needs to be sedimented and then filtered out. Then remove the dissolved gases, the gases which will create problem, as we say, from the corrosion point of view, they should be removed. And we should do the chemical treatment also, as I say, for scaling, for soiling and other things. So we will be using HCl, and at the same time we will use some specialized chemicals which will take care of the impact of bacteria growth, the impact of corrosion, and the impact of scaling. So we'll have the chemical treatment also. And these are the testings we should do for having this smooth operation of water injection. One is total dissolved solids quantum, pH and hardness, turbidity, that is an nephrometer turbidity unit. This shows basically the colloidal aspects of the water which is being injected. Then we should measure for dissolved oxygen, CO2 and H2S, corrosion rate, and of course BOD and CO2, that is biological oxygen demand and chemical oxygen demand. They are also to be measured for having smooth water injection operation. How much quantity is required, that needs to be estimated or evaluated in the beginning itself. As I said, that if we have taken some production from any mature fields or the field which has been put on production for quite a long time, so now we can understand how much voidage has happened. So we'll have to calculate that voidage quantum, and accordingly we'll have to estimate the quantity of water. And care must be taken to prevent loss of water due to failure of cement bonding. So in any well, basically as there are cement bonding, all this surface of this, external surface of this tubing, because of taking the rigidity of the piping. So there is a possibility that the water can go through that leakage of the cement, that cementing failure or whatever. So that is to be also seen. The cement bonding failure, whether it can create the loss of water, that is also to be understood for estimating the water quantity. Water requirement is also influenced by rate of injectivity, that is change in injection pattern. As we said, there are injection pattern which we have to identify in the beginning itself. Now if we would like to change them, the pattern, the well depth, the time gap and all those things, so they are also equally important for calculating the injection water. So injection water although it will be quantity is known in the beginning itself, but we need to re-evaluate or re-estimate from time to time. And when we have already understood how much quantity of water is to be injected, now we'll have to go for drilling of a new well, which will be known as now water injection well. So this is the water injection well. The water injection well and oil production well procedure is exactly same. So it's not that different procedures are there. All the casings, the annulus, the tubings, everything is similar, and even the perforation also is similar. Only the layer will be a little different for perforation and for production. While the production will be from oil and water interface, but the water injection will be exclusively in the water layer. So it is little further deeper from oil well in that particular well. It's not that because everywhere the depth are changing, but if we have to take about this field basically where the oil well is there, there only we will have to consider around 2 to 3 meter below that oil zone. This perforation has to be done. So the new initial completion will happen, drilling of new water injection well and conversion of existing well. Sometimes what we do, the production well which is not now producing because the quantum has reduced to very little quantity, there we can go for conversion of that well into water injection well. As I said, everything is similar, so there won't be any problem to get it converted. The selective plugging of thick zones, and as they are called thick zones, means in case the cementing is bonding is not good, or even inside the formation also, if you find some good or the big fractures, so they will be thick, known as thick zones, means water can go towards that instead of going for displacing the oil. So we'll have to see the thick zones availability, and we'll have to detect them and then plug them. We can plug them also. If we can detect them, then we'll be able to put some you can say fluids or some muds sort of thing that can ultimately close those thick zones or plug those thick zones. And in case we go for new water injection well, it is, as I said, it is exactly similar. So it will not be required to convert it any producing oil. It will be drilled newly from top to bottom. This is what is happening, as I had explained, that how the perforation and all those things will be taken care. In case of only as the tubing which was initially lowered for oil production now will be utilized for water injection, so we may have to go for change of tubing also. In case the same tubing can be okay for water injection also, then it is not required. Otherwise, simply this is called pulling out of production completion, means whatever production pipings are there, that will be pulled out and then running in of new water injection, and other things will be more or less similar as it was there earlier. This is the detection of thick zones. As we are saying that thick zones may happen inside failure inside the formation also. And there are some equipment or instruments available to identify the thick zone. One is called continuous flow meter, means if we follow the quantum, and if in case we find sudden ingress or outgress, that means we can understand that there are certain thick zones. But if it goes smoothly at the same rate, then means it will not be there. So continuous flow meter will be used for logging the thick zone. And otherwise some tracer also can be put. We can put some tracer also, and in case that tracer is not coming here, that means there are thick zones, but in case it comes back here, then thick zones are not there. So plugging of thick zones, what we use basically: talc, zinc oxide, cement, colloid, resin. These are the materials which can be used for plugging the thick zones. Agents are injected in the form of particles. Particles travel until trapped in front of core. The following particles will then back up behind it, and the formation will become plugged. The effect can be accentuated if a swelling material is used. In case of unplugging required, the precipitates may be dissolved by HCl. So basically, these materials are utilized in a particular procedure, and in that way, these thief zones can be blocked. In case if we feel that they need to be reopened, then we can inject HCl, hydrochloric acid. The hydrochloric acid will melt or will dissolve these materials which will be used for plugging the thief zones. And preparation of injection well. In case we have to now, as we have said that injection wells or has been drilled newly or converted from the production well, and the thief zones also have been plugged. Now, what we do basically when we really go for injection well, sometimes we take some production from that well itself. As I said that injection well and production well are exactly similar. So in the beginning, before injection, we can take some production from that oil also, from that injection well also. Because in that case, what will happen? The pressure nearby will go down. So now it will be more beneficial for water injection because water can easily now go to the formation. So that's why sometimes after drilling a new well for water injection, we take production from that injection well for some period. And displacement mechanics, how this displacement is happening, because as I said that these are all, this white circle, they are all producing well, and this blue circle injection well. So what will happen? Sorry, blue is the water injection wells and white is the producing well. So they are displacing basically. Whatever is there, they are getting displaced and coming to this producing well. So this commencement of water injection starts increase of pressure. One is the pressure increase in the reservoir is there. Second is around the injection wells, the displacement also will take place. So these are the two benefits what we get from water injection. And these are all steps basically are shown. So we will not go into details. Only simple thing, basically stepwise how these movements are taking place in the formation. Now we'll go for a case study. Basically, it is a case study for offshore water injection. So in case we are to go for water injection in offshore, so definitely the source of water will be seawater. Okay, because we can take the water which is coming along with the wells also, but they need to be collected from a single location, because in offshore you will find in earlier occasions we had explained that oil processing platform does not have any big vessels to store either oil or water, etc. So they are small in size and taking place continuously. But if in case we have to go for water injection, then we'll have to collect them and in some gathering locations. So that is not possible. So that's why we prefer to use the seawater. And then what are the steps involved? Seawater lifting means this is they are all you will see it clearly. There is a column basically, and in that vertical column, the seawater is being lifted. There are many other risers you are saying for taking the water to the injection wells. The pipelines are there, all those things. But there is a single column also that takes for seawater to be lifted. And so there are pumps basically, and then course we'll go into the details of that. Okay, coarse filtration for removing the suspended particles, fine filtration, even more finer particles required to be removed, otherwise they will choke the pores. Deoxygenation, as I say, that the corrosion may happen, so the deoxygenation has to happen. These are all deoxygenation tower, means vacuum tower. In that way, we can remove the all dissolved air and oxygen, or even chlorine gas also dissolved. They can be removed in these towers. Then dosing of chemicals, we'll put many chemicals, as we said earlier also. Then finally, we'll pump the treated water for injection. This is the typical flow diagram. You see, this is the seawater being lifted. This is the coarse filter. This is the fine filter, and before fine filter we inject coagulant and polyelectrolyte. They are the two chemicals which will be used so that the particles will get coagulated, so they will make little bigger sizes so that easily they can be separated here. And this is coarse filter. And this is the deoxidation tower. And finally, it is being pumped in two stages: booster pump and main injection pump, and then going into the water injection. So this is a very simple flow diagram which is required for water injection in offshore. In fact, if we go for onshore also, the same schematic diagrams will work. Only thing is the source of water will be different, and maybe the filtration will not be required twice. Only in single stage may work. And in case oxygen is not much in those fresh water like sea water, then we can skip that also. By putting the chemicals only, we can take care of that. Seawater lifting means that you see, this is very important, that this is the vertical line, you see, and the pumps are lowered 30 meter below sea level, mean sea level. Why 30 meter below? Because the water depth here is 70 meter. So if we take water from the top, from the surface, as the surface is open to air, so definitely the oxygen quantum will be more. So that means we'll have to have more processing requirement for removal of oxygen. So it's better if we go down. Now if we take further down, suppose minus 32, even minus 60, 70, then what will happen? The suspended particles will come because soil is there. So that's why this 30 meter below is the optimum depth for lifting this water from offshore water injection wells. And usually the centrifugal pumps will be utilized, which develops pressure of 8 kg per centimeter square, and 42-inch casings are utilized. But that depends on these parameters are depending at different locations based on the quantity of water to be handled. And we use chlorinator. This is the chlorinator, means sodium hypochlorite is being produced by electrolysis, because instead of purchasing bleaching powder, we can go for NaOCl manufacturing there itself, and that we can inject at the dosing line, because in case we use it here, then what will happen? This chlorine ppm or the sodium hypochlorite, that will kill all the living organisms. All the living organisms, means whatever bacteria, algae, and all those things likely to come inside this, those will get killed. So they cannot come up. Means even if they come up, they will be totally dead. So that's why this chlorine ppm has to be maintained at the outlet of this seawater leak pump. Because if we monitor some chlorine here, that means we ensure that whatever chlorine is required to kill them, that has been fulfilled. Then we said we'll have coarse filter. These are all coarse filter. They have the cloths actually in between, the cylindrical cloths. So that removes 80 microns or larger. And cylindrical metal filter wound up with cloth. Raw water flow from center to outer annulus. Means when we inject or flow the water, that will go from center to outer. Simultaneous backwashing through a rotating element. Now, as this cloth will have the deposition of suspended particles, then we should backwash, and the backwash will be in the reverse way, that is from outer to center, So both the things can take place simultaneously also. Suppose if one filter is under filtration, the other one will be under backwashing. And automatic sequencer will be there. This can be operated in sequence automatically. The time they will be operated based on two parameters. One is the time difference, which is pre-scheduled. Another is the delta P. In case the pressure difference across the filter outlet and filter inlet is very high, that means a lot of deposition is there. So we should go for backwashing. And we can bypass also. In case we find that these cloths are to be taken for maintenance, we can sustain the operation by bypassing it also. And in case of fine filtration, you see these are fine filtration. This is not, no cloth is there. These are all filter beds. The lower one is large gravel particles, fine gravel particles, fine sands, and anthracite. Anthracite is the main, basically to use for removal of 2 microns. Okay. And in this time, what will happen? The water will come from the top and will be collected from the bottom. And while backwash will take place, when the sediments have already been deposited along with the particles, they need to be backwashed. That time we will utilize this path. Okay. So these valves are operated again in sequence or based on the delta P. And as we said, we utilize coagulant and polyelectrolyte because they can help in coagulating the small particles to the bigger sizes. Either even if they are based on electrolytic property or even non-electrolytic. So that's why we put both the chemicals for this purpose. And in this case, there is no bypass. As this is the fine filtration, we cannot bypass it. So we will have to have fine filtration always in line. Otherwise, no seawater can be taken for next step. And the suspended solids quantum will come down to 0.05 ppm. Then we will be taking the deoxygenation tower. This is our deoxygenation tower. The vacuums are being created through vacuum pump, and two-stage vacuums are there so that more effective oxygen separation will be there or air separation will be there. The second stage will have additional vacuum by passing through the ejector. So this is the internal or tray type or column type, and it removes dissolved oxygen. Two stages of vacuum is 42 millimeter mercury and 20 millimeter mercury. Polypropylene rings are there inside. Vacuum pumps and venturi type ejectors are there to create a vacuum. Dosing also is required, defoamer, because if we put water from the top, there is a natural tendency that in empty vessel or whenever the open space is there, there is a chance of getting foam created. So we should use some chemicals for defoaming. Otherwise, the oxygen separation will not be very useful. So that's why this defoaming use is very much important for deoxygenation tower. And vertical downward flow will be there, and dosing of oxygen scavenger also will take place. Other than this physical exercise of vacuum creation for removal of oxygen, we use some chemical also, oxygen scavenger. They can also reduce the oxygen ppm in water. And here also no bypass arrangement. Means we will have to continue with deoxygenation tower as long as we operate the water injection plant. The booster and main injection pumps. The booster pumps means actually here you have got at vacuum. Now we will be putting the pumps in such a level that there will be some head automatically created because of this level difference. And in that level we may get 1 kg, but that 1 kg needs to be pumped to 125 kg. So instead of going directly through this main injection pump, what we do, we first take the booster pump. This is booster pump, and here the outlet pressure is 9 kg. This is centrifugal pumps. And another important aspect is that we need to inject some corrosion inhibitor, scale inhibitor, and bactericide. So if we directly go for main injection, so we'll have to inject these chemicals at very higher pressure. So that's why what we do, we go for two stages of pumping system. One is booster. After that, the chemicals will be dosed, and then they will be taking to main injection pump. So the main injection pumps inlet pressure is the outlet pressure of the booster. There is no vessel inside. Directly this water will be, the outlet water will come into the suction of this main injection pump. And the main injection pumps also are centrifugal because usually the quantity of water to be handled is very large. So that's why instead of reciprocating pump, we need to use the centrifugal pump. But here we will be using multi-stage centrifugal pumps. Usually 3 stages are used. We can even go for higher stages. That depends on how much maximum pressure you have to create through this main injection pump. Then high pressure water flows to water injection wells through strainer. Finally, we will use some strainer in case any pipeline rust or any suspended solids still could come inside, or the clogging of these chemicals, etc. So they will be strained out, and they will be utilized to flow straightener and turbine meter. They need to be measured in turbine meter. This is a typical water injection wellhead platform. In offshore, you see this is a platform. We had already explained that day how the well platform looks like for offshore. See, these are all wells. You see all the black color, they are all wells. They are all producing wells or water injection wells. In case of oil production well platform, they are all producing wells. In case of water injection, they are all water injection wells. So here the water will go from this way. And this is a small bunkhouse, you can say. In case the people would like to stay there because of extra work, they can stay there. The beds and all those things are there. Generators are there. The helicopter helipad is there. And even this is called boat landing. If the people are to be there to come through boats, it is possible to come there also. We have personally, we have all stayed there for quite a long time for commissioning of water injection, and later on also for maintaining the oil and gas production in the offshore field. So now in oil platform, they are having mainly two aspects. One is the metering, another is pressure indicator. So pressure indicator is required whether the appropriate pressure is being maintained or not, and metering is required how much quantity of water is to be injected, that is being justified or not. And the platform contains number of wells. Actually, all the wells are not vertically down. After that, they will be inclined or deviated, so that more area can be taken up. From the top, it looks like all are vertically down, but under the water, they will be almost, you can say, 400 to 5 meter across this vertical line. They will be spread at the reservoir. Then we will have manifold, means we will have to segregate the main water into the several lines. So the manifold will be there. Pig launcher and pig receiver will be there. All the pipelines. This is, suppose this is a water injection line. Okay, this is a water injection line which has come from distance to this platform. This line is to be picked, means this line is to be cleaned time to time, because inside this piping or inside this pipeline, there is a scope of scaling and formation of bactericide, corrosion, and all those things. So pig is basically a foam type of, you can say, bucket. So that is pushed from the pumping station and it's collected here. There is a facility, pig receiver, we can collect it there. So this is called a pig launcher and receiver. Shutdown panel is there to operate all the wells. Fire and safety devices, of course, will be there. Although water injection as such is not combustible, but even then we have the generator, diesel, and all those things are there. So obviously fire and safety devices are required to be there. And solar panel and telemetry system, telemetry for operating or monitoring the things from distance. And there is a vent also. In case this water injection wells are to be taken on production in the beginning, this can be utilized for venting the gas also. So all these facilities are available in case of water injection well platform. And these are all templates. This is 4-leg templates. Means there are 4 legs which is required for keeping this platform stable over the water. These 4 legs are touching the soil. Okay. Then scale inhibitor, this chemical is being utilized using this sort of dosing pumps. Usually strontium sulfate is the scale which is problematic. We have the calcium sulfate also, but strontium sulfate is more difficult. Once it gets created, it needs to be separated out. It is insoluble in most of the conventional solvents like HCl, can form inside the reservoir or in the tubing and can seize the production. Scale is formed while mixing of formation water and seawater. So as there is no physical procedure to separate out the scaling, so you use the scale inhibitor chemicals to take care of that. And it is to be used regularly. Then drag reducing agent. Actually, the water has to move inside the formation very easily. There should not be some drag force which will create the problem for water to flow inside. So we should use some chemical which will reduce the agent. You can say some surfactant type or soap type of solutions can be utilized, which will be effective for reducing the drag force. And use of drag reducing agent increases the pumping rate. Obviously, if we use that, then as the drag force is reduced, so we will be getting more pumping. And if more pumping is there, obviously number of injections will be less, and energy consumption also will be less, and corrosion chances also will be less. So there are many benefits happening because of use of drag reducing agents. We can will need to monitor the corrosion also before we go for corrosion prevention through the corrosion inhibitors. One is iron count monitoring. there is spectrophotometric and direct reading can be utilized. Weight loss coupon, we use some metallic coupons and take the erosion or the reduced coupons weight, and the loss of weight will be the signal for the corrosion being taken place, or the corrosion probes. Directly we can use some corrosion probes, and through instrument you can directly measure in mils per year. This is the unit mils per year, that is millinch per annum. This is the admissible rate, and it has to be less than that. And regular dosing of corrosion emitter inhibits corrosion formation. Then these are the parameters which are required to be monitored. Just go through, you need not to memorize at all. The total suspended solid less than 0.2, total suspended solid particles per milliliter less than 600 and above 2 micron size, TSS NTU less than 0.15, oxygen ppm less than 0.03, sulfide ppm less than 0.1, free chlorine ppm above 0.2, SRB sulfide reducing bacteria less than 10, and millipore. This is the rate of smoothness of water being taken for injection. So that test is called millipore, 10 liters in 30 minutes. These are the parameters to be checked time to time with regular interval whether the water quality is permissible for injection or not. And then finally we should go for maintenance of water injection system. So once we have installed everything, what we have clarified, how to go for water injection wells, then the processing of water injection. Finally, we need to maintain the total system. And in that, what are the things to be looked into? Water quality control, physically, chemically, and biologically, corrosion control, regular inspection of surface equipments, whether any pipeline leakage is there, or any leakage from the flanges, whether the valves are being operated properly or not. In case of real emergency, whether the valves can rotate freely or not. Pigging of the pipelines, as I say, that pipeline needs to be cleaned time to time. So the pigging operation to avoid the choking, corrosion, and all those things. And regular inspection of injection wells. These are all for system, and these are for wells. Temperature survey, time to time we'll have to go for logging, the starting and injecting conditions, temperature survey, annulus pressure, we'll have to see the pressure checking also, because they are all signaling of how smoothly the water injection will continue. And routinely recording of wellhead pressures, skin effect from pressure follow-up test. All these basically, whether the formation damage is there or not, that needs to be verified through skin effect. So there are proper tools actually. For all these, there are proper tools. They need to be monitored by taking the reading or by lowering the tools and taking the reading. Then daily recording of injection pressure and injected quantity, injectivity test in every 3 months, backwashing, and production logging. So what we had explained basically, those things need to be monitored time to time. And finally, we should go for tracer. Means we'll put some isotopes. And when we put this or mix this isotope at the injection well along with that main injection pump outlet, finally it has to come from the producing well. In case it is coming from the producing well, we can say that the water injection is completed, because now this water front, see here, so this is injection well, this is production well. So if we put the tracer and get the tracer from here, so that means now no more water injection is required, because now whatever water will be put, that will straight away come from this well. So if the tracer comes, we will have to be getting the signal that water injection is not to be continued. Okay, so this is tracer for knowing the sweeping efficiency to detect the breakthrough of water from injection well. So what are the tracer materials? Formaldehyde, thiocyanate, nitrates, dichromate, iodides, etc. Dosing is at 1000 ppm and duration is around 2 days. Tracers are used to track the frontal advance of water. Tracer arrival times from injection wells to producer wells help to determine the sweeping efficiency. So if they are coming very quickly, that means water breakthrough has happened. So we should not continue water injection from that location. So finally, what we can conclude that if we do not do the water injection, so definitely the pressure will go down, and the primary recovery means whatever original oil in place available in a reservoir, we can get only 15 to 30% with the natural energy, means without putting any water injection. But if we go for water injection or pressure maintenance by any other means, that means we will be able to increase this recovery factor from 15 to 30 to 40 to 45. So a lot of gain will be there by maintaining the pressure by water injection. So water injection being a proven practice to increase the oil recovery from 15 to 30 to 40 to 45, most of the E&P company prefer it rather than venturing for the new fields. So it is another advantage is that whether the oil and gas producer will go for water injection or will look for drilling a new well to take more production. So definitely this will be better, because in case we take for new well for production, again we will get only 15 to 30%, not beyond that. So finally, if we have to take more and more production from the same well, we'll have to go for water injection. That's all. This is the total for water injection. Now let me find out whether you have understood or not. You have any question? Participants? Do you have any question? Okay, let me ask one. Galaxy A10. Who is there in Galaxy A10? Can you sound? Galaxy A10. What happened? Who is the next one? Sayan Mukherjee. Sayan Mukherjee, are you there?
Yes, sir.
What you could understand in single line? You need not to explain anything, only through this presentation what we have focused. Just say in one sentence.
Mainly on injection process, water injection. By the injection process, how to increase the pressure inside the rock.
Reservoir, yeah.
Yes, sir.
Yeah. Do you think that it is an essential requirement for any oil
Yes,
and
sir.
gas field to do it?
Yes, sir. Especially in the offshore process, it is very much required, as because at the last moment when the production falls down, at that time, sir, water injection is one of the vital phase, sir.
Yeah.
I think so.
It is practically not only applicable for offshore. In fact, even for onshore also, wherever any field is getting matured, means with time we have taken some quantum of production, be it gas, oil and water. So the pressure will go down and we need to increase the pressure through water injection or any other way for maintaining the pressure. So obviously offshore, as the quantum of offshore production is very high, that's why it came in your mind. But practically for the oil and gas producer, they look for such facility to be created every places, in fact.
Yes.
But more the quantum of production, definitely it will be more economic to start the water injection in that location. Suppose in a particular location where only two, for example, Ashok Nagar, for example, you have got only one or two wells now to produce. In case this field is so small that you cannot go for more production, then to invest money for water injection and to take this additional 15% production may not be justifiable. Because for water injection, again, you need to create a lot of facility, many number of injection wells, as you have clarified, the processing facilities to be created, all those things. But in case the production itself is very less, so to increase of that production by another 15% or 20%, also will not be very, you can say, commercially viable.
Cost efficient.
Yeah. So that's why for small fields, it is not okay. But
Okay.
irrespective of onshore and offshore, for large fields, it is very much required. Okay.
Okay, sir. Thank you, sir.
Let me find out one more question. Ishika Samanta, is it there? Ishika, are you there?
Yes, sir.
What comes in your mind after listening to this 1 hour?
Sir, the injection process, why water is used, and how we can, all the benefits and drawbacks, everything.
Whether it was known to you,
No, sir. It was new to me.
means anyway it came in your mind by listening from someone or by discussing with someone that this sort of activity goes in the oil and gas field.
No, sir, I was not aware of this.
Is there anybody who have heard of water injection required for any oil and gas field anytime? Is there anyone who can say simply yes or no? He need not to explain, he or she. Only say yes, I was aware of this.
Sir, in the previous class, in this course, in the previous class, someone said that instead of water or gas, we can use both.
Yeah.
We can inject gas also
Means
Sir,
through this course
before
only.
your
to
speech,
increase this
sir,
pressure.
one from Abu Dhabi, he speaks about this.
Yeah. So means you have learned from this internship course only, right?
Yes, sir.
Yeah. Means
Yes, sir.
this sort of information was not at all with you by any means. Only you came to know that you have heard so far of oil and gas production. Maybe that oil and gas is being processed in the refinery for further production, all those things to certain extent. Although not in details the way it is being covered right now. But this aspect, like what we say for water injection as such, for the last 1 hour, what we explained, how it has happened, why it is required, is it essential or not? If it is required, what are the things to be considered? What are the processing steps being followed, and where it is required? All those things definitely are not known to you, it seems, right?
Yes, sir. These are all new, sir.
Yes, sir. Today we know that water should be deoxygenated and it should be filtered unless corrosion can occur inside the pipeline.
Yes. So basically, the process is very simple, but there are many reasons behind for choosing the processing steps basically for so that this plant can run for 20, 25, 30 years without any problem and will give the effective results, right?
Yes, sir.
Because why these particles are to be removed, why the oxygen ppm is to be removed or totally reduced to zero almost, why one more thing, actually there we have to go for another, okay. So only thing is that while we did the commissioning of this system, first time it has happened in ONGC and in offshore, and my first posting was there eventually. So the platform what I shown you also in the beginning,
In which year?
1983.
Okay, sir.
This platform. I was staying here. This is the living quarter. This side is the living, and this is the oil production platform. From here, the oil and gas being produced. This came almost in 1978, and this has come in 83, and then they are connected through bridge. That Mr. P.K. Sen Sharma has explained how the bridge is being and how these platforms are being raised in the offshore. So this is the platform what we operated, and we, because if someone stays or someone is getting chance of commissioning, they know many things which was theoretically described, but practically they have been faced basically. And secondly, they required to do some modification in that also, the way we did actually. What happened in the fine filtration system, for example, here we found that a lot of anthracite loss is there. Anthracite is very costly, first of all, and not only from money point of view, to get it in offshore, because offshore, as you say there are not much space available for storing all those things. So it is very difficult to get these materials always available in abundant. So as this anthracite is getting lost through this, when the backwashing is there, it is getting lost. And it was not known how it is getting lost actually. It was very difficult, because if we collect this water sample from here, we found that no water sample could be collected here, because there is a suction. The reason is when the backwashing is taking place, this water is going from this level to this bottom, and there is a hydrostatic head. So if you do not collect the sample from this level, you will not get anything. You will get only the suction or vacuum sort of things, ejector sort of things. So because the water is passing heavily, and you will not be able to get any anthracite which is coming or not, because no sample is being able to be collected there. So we need to put what we did, we put a tubing here. Not the main pipeline has gone, and from that one tubing, PVC tubing, maybe 1 inch or so, we have lowered up to that boat landing, and then we collected the sample, and then we found that yes, anthracite is getting lost to that. So we put one mesh or strainer here, so that no anthracite is being lost now. So there are many things like here this is called chlorinator. We need to inject chlorine, as you say, because we will have to kill all the living organisms. Now all the living organisms to be killed means sufficient quantum of sodium hypochlorite should be there, and unless you get 0.2 ppm of residual chlorine at seawater outlet, the chemist also will not allow for any water injection. So a lot of time was being wasted. So what we did, initially we put a lot of hypochlorite concentration and put it there. Normally, suppose if it is required 200 ppm, we produced at 500 ppm. And if we inject that initially, then there will be the result very quickly, and then we go down to 200. So these sort of things which are not there for the manual also to describe, to be followed, we came out with such solution. So like that, there are many. I mean, we are talking about few. At every step, basically, we had to do some internal modification in operation, because construction we cannot go. In operation we can, and those things have basically influenced to take better results, and those are being followed now also. So this is what happens basically.
Sir,
Okay.
I have a question apart from this.
Yeah, go ahead.
Sir, is the sir in offshore platform, is there any high power cutoff to work there?
Is there any?
High power cutoff?
No. Only medical health is required. Eyesight.
Sir, I have a high power of minus 4.5. So
eyesight,
can I work?
yeah. Eyesight. So far, of course, we have a doctor on board also. He will monitor whether your movements are problematic or not. In case through lens you are able to manage like normal, then there is no objection. I do not believe. In fact, I had taken the medical help not to continue with the work in offshore, because I was so thin that time, only 42 kilo, and operating with helicopters, and I was posting men as well as the location. So a lot of helicopter movements are there, even boat landing operations also. We had to do the jumping and all those things. Everything we have done actually. So I was obviously scared also. Okay. So I told the doctor that this place is not suitable. The doctor just examined me and said, no, you are medically fit. So that could not be useful. So there is no problem as such. As long as you are healthy, I mean, in a sense, yeah.
Okay, sir, then I can work, right?
Yeah. I do not find any criteria is made for eyesight.
Sir, usually what is the working hours as a engineer, sir, on the offshore?
12 hours. 12 hours a day.
And sir, is it possible, sir, to return on that same day?
No.
Then
Because
we have to sustain there.
You will have to remain there
No,
for
15 days
14
or
days.
21 days.
14 days. In
14
some places 21 days, in some places 28 days, 14 days, but in our ONGC, 14 days. Means
Okay,
14
and
days you have to
there is
stay.
also accommodation.
Yeah, these are all accommodation. I say this is the platform.
Okay.
You are to remain within this area. I mean, not you only. Almost 150 to 300 people. I mean, sometimes it goes up to 300 also. That depends on contract labors also. Otherwise, 150 is the normal capacity, and so many people are there, and bunkhouse is there. Food is free. Almost a 5-star arrangement is there inside the living quarter. So
Can
and
one
all.
sleep without any hesitation? Can one sleep properly?
Yeah, because living quarters are totally soundless. Even
Okay.
at your home, you may be getting some external sound, no, but there you won't get anything. They are two layered actually. All the doors are having two layered, and pressurized chamber is there. I mean, the pressure inside is little more. I mean, little means very less, but because so that outside thrust of air will not come inside, or any smoke or pollution, nothing will come inside. So HVAC system is there. Not only AC system, it is called humid and ventilation system. So the humidity and ventilation also have to be properly managed or maintained in such locations. So and all foods are being prepared there, everything. So this is the place, what I say. And you see in this case there are two helicopter landing possible here as well as here. Okay. So staying as such is not a problem. Only you need to remain there only for 14 days continuously. So in that 14 days,
And sir,
your work will be 12 hours. Okay.
Okay, sir. Thank you, sir.
sir, and if a cyclone comes,
So those we have already stayed there for so many, and the platforms are there now also. So actually, that day I was explaining about deep water also, no, the drill ships and semi-submersible ships in East Coast. Even the hurricane or wind speed is very high. Even then, even in monsoon also people do stay there. There are very rare occasions are there whether the places are to be evacuated. So they are all cyclone proof. There is no problem as such. Okay.
Sir, in a onshore, in a
Okay, sir.
offshore, sir, there is a constant fire, sir. What is that function, sir? Constant fire.
No,
going
that is called flare.
Clear. Yeah, oh, yes,
Flare,
sir.
yeah. Actually, you see, even in offshore also we have the flare system. It is water injection. That's why the continuous flare is not there. But where the oil and gas processing is there, we have a flare because the low pressure gas, very low pressure gas, which cannot be recompressed and taken back into a mainstream. For example, suppose we have got a separator which takes at 1 kg per centimeter square. So that gas, if you have to compress, it needs huge money to invest again. So those gases, or even from wherever the atmospheric stabilization is there, suppose in an open scenario, the tank is being maintained because the oil needs to be stabilized totally free from gas so that it can go to the tanker for transportation, because tanker cannot take any gas along with the oil. So those gases definitely needs to be continuously vented, because if they are not burned, then what will happen? They are more poisonous. In terms of hydrocarbon, more poisonous than CO2. And as well as fire hazardous also. Hydrocarbons are environmental problem as well as fire hazards. But if we put it into CO2 after flaring and firing, then those problems will not be there. So that's why every industry, you will find that flaring system is required. And even if major gas is, exit of gas is not there, but that flare needs to be always burned, because otherwise sometimes if it is not burnt and sudden gas has come out, so that gas will go without any fire, so that will create problem. So that's why continuous, that is called technical flaring, needs to be done. So every process complex is designed for such technical flaring continuously, and then when the exit of some high quantum of gas will be there, then definitely it will take care of burning of that also, right?
Okay, sir.
This
Thank
is
you, sir.
everywhere, not only for onshore, any process complex, wherever hydrocarbon
Yes.
is being utilized, everywhere you will find this, because you will have to have a safe, this is called zero flare also, you can say, or the technical flare, that has to be there to take care of any exigency when some rupture is there or malfunction is there, shutdown is there, sudden exposure of extra quantity of gas can be flared with burning. Without burning, nothing can go. Right.
Okay, sir.
Okay. Now let us close it here, because We'll have to finish by 6 and so can you see now?
Yes, sir.
What
Yes,
you can
sir.
what you can see? What is written?
Sir, enhanced oil recovery
Sir.
from mature oil fields.
And what is the meaning of that? So far, what you can understand from this? Just,
The remains
just
the
yeah.
remains oil, sir, the, means last portion of oils. How to exact?
Yeah, means in our earlier lecture, what we said that 15 to 30% can go up to 40 to 45%, but still it is not touching 100%, you know, because still some oil are left in the reservoir, right? So this is another step to go for more production from that location. Okay, that is called enhanced oil recovery from mature oil fields. So this picture is saying primary, secondary. We'll explain that. Okay. So what we'll go it very quickly now. Okay, and I think many of the things are almost explained. We'll not explain right now. When you will get this presentation, you will understand them of your own also. Okay. So we need not to explain in details now. Introduction, your techniques, your means enhanced oil recovery, implications, your principle, your costs, global your production, Indian scenario, selection criteria, life cycle, and conclusion. And enhanced oil recovery or tertiary recovery includes all methods that use external source of energy or materials to recover oil that cannot be produced by economically conventional methods. Means whatever we have produced earlier by primary recovery by using natural flow or artificial lift. Artificial lift that we had already explained that Saccharod pump, submersible pump or gas lift, they are utilized for primary recovery of production. Then we have gone pressure maintenance or water flooding for secondary recovery. Now we are for tertiary recovery, and this can take the production above 50% and up to 80%. So you can estimate now up to 80% is possible to be recovered if we use this enhanced oil recovery. And world recovery average is now 22%. So it is quite, I mean, the future is very bright. You can say from that perspective. USA recovery is 39% and India is 32%. And in case of primary recovery, suppose water flooding and CO2 is not there, then the production will stop here. But if we go for water flooding, then we can go up to here. And if we go for CO2, then we can. So this way we can continuously take production for even longer time. So primary recovery we had already explained. So we need not to go in details, just we'll read it. The oil well is created by drilling a hole into the earth with an oil rig. Few steel pipes casings are placed in the hole to provide structural integrity in the new wellbore. Holes are then made in the base so that the oil is connected with the reservoir through wellbore. Finally, a collection of valves called Christmas tree is fitted to the top. In this situation, it is necessary to connect the Christmas tree with the pipeline network for processing. Then after that, there is a processing facility. And if the underground pressure in the oil reservoir is sufficient, then the pressure will force the oil. So if the pressure is sufficient, that will force the oil to come to the surface. In case the pressure goes down, then we'll have to go for SRP, ESP or gas lift. So when we go for this artificial lift, means we are not doing anything in the reservoir. Whatever we are doing, that is up to this oil bore only. We have not done anything in the reservoir in case of primary recovery. Now we go for secondary recovery. We are doing through water injection, as we explained. So here, what we have done something in the reservoir. You see, what we have done, we have increased the pressure. So we need to explain this now. And tertiary recovery means it involves injection of different materials in the mature oil fields or mature reservoirs to recover oil remaining after the primary and secondary recovery phases. The process of EOR can be classified into 4 major groups. Thermal, try to remember these things. I mean, not essential right now, but at least just by listening, thermal, chemical, miscible gas or gas, and others like microbial. They are the 4 procedures which are required to be utilized for enhanced oil. And these are the criteria basically we need to explain right now. Thermal EOR. What is thermal EOR? Thermal EOR uses thermal energy. Means we have to increase the temperature of the reservoir. Because if we increase the temperature, what will happen? The viscosity will get reduced. So this part is to be understood. That viscosity goes down if in case temperature increases. And in case the viscosity is less, then what will happen? The mobility will be better because the resistance force will go down. The drag force will go down. So more and more easy flow will be there. So this particular topic is talking about use some thermal energy to increase the temperature, and that can be done by cyclic steam injection, that is half and puff method, continuous steam injection, hot water injection, steam assisted gravity drainage system, and in situ combustion or fire flooding. We will explain these 5. Okay, let me tell first one is cyclic steam injection. Means what is happening? This was your producing well. Okay, in that producing well, earlier the production was coming. Now you have put some steam. Sorry, you have put some steam. Okay, if you have put some steam here, now this steam, this is surrounded by steam now. Now you have closed for some time for soaking. So this oil is now having low viscous because the viscosity will go down. Then if you open it again, so this oil will now be easily possible to come up. So this is called cyclic steam injection, also known as half and puff. Half and puff because the same oil can be utilized for injection as well as production. Only when the injection will be there won't be any production. And when the production will be there won't be any injection. So a single oil, when it can be utilized for both the operations time to time, that will be known as cyclic steam injection. Continuous steam injection, this is different, means here we have continuously to inject steam from a distant location. Like water injection, here we are injecting steam. If in case we inject steam, that steam will flow from that perforation like this, and this will increase the temperature. And if it increases the temperature, as we had explained, the viscosity will go down and the formation will be easier for oil movement, and so oil can come there. So what is happening? This process is known as steam drive method. Injection of steam in several injection wells while the oil is produced from other wells. Some thermal energy is lost through the reservoir, especially in deeper wells. Means while we do that for deeper wells, there is a loss of some temperature because of more depth. So those things are to be remembered. There are some more explanations. We will not explain in details, it will take time. And we can go for hot water also. So first we have gone for steam, either half and puff or continuous. Now we can go for hot water. Means steam will not be injected. The water will be at high pressure. Before steam formation, we will inject it. Even then it will carry some temperature, and that will be used for taking more production. Steam assisted gravity drainage. Here what will happen? You see like this. This is this green one is your oil production line. Okay. And this is the steam injection line. So here they are horizontal. At some depth, they are horizontal. Means the steam will basically increase the temperature here, and the oil will get deposited, and that will be come inside and then go. So the vertical perforation is not there. The horizontal perforation is there. And through that horizontal perforation, we can get more area to be covered by steam assisted. And finally, we can go for in situ combustion. Means instead of using hot water or steam from the top, we can use air or oxygen from the top, and we can fire some of the oil here itself. Some oil will be fired here, means combusted here in the reservoir itself, in the bottom, because normally although it is combustible, as there is no oxygen, so no fire is taking place. But if we put some controlled oxygen or air from the top, then some quantum of oil can be burned there, and that will create heat, and that heat will take care of the reducing the viscosity of the distant oil, and in that way it will facilitate the oil production. So in situ combustion, which is known also as fire starting. So these are the 5 methodology which can be utilized for increasing the temperature in the formation, and increased temperature will reduce the viscosity, and reduction of viscosity will increase the mobility, or the resistance force will get reduced. So more oil production can be made available. In general, the oil which is heavy, basically, which has got more heavier cut, that will be having better result for all sort of thermal energy or thermal, you can say thermal EOR method. Okay. The next is gas injection. Instead of thermal, if we inject gas, now what will happen? Gas injection EOR involves injection of gaseous fluids in the reservoir to enhance ionic pressure with the formation. First of all, it will increase the pressure, as we have already explained for water injection. If we put gas injection, definitely it will increase the pressure. Secondly, gas injection sweeps the formation for remaining fluids. It will have also, like water, it will have very good sweeping efficiency. So that will boost the oil production. Gas injection is always carried out through separate oils, so that the remaining oil can continue. Means the same oil cannot be utilized for gas injection. Earlier we have shown that the half and puff steam injection method can utilize the same oil for same producing oil for additional production, but here we will have to have a separate gas injection oil. Okay, and gas injection EOR may be carried out by natural gas or any other hydrocarbon, maybe it's LPG, nitrogen also, carbon dioxide also, flue gas also. So the answer we will be getting right now after 2-3 slides, that what sort of benefit we can get by carbon dioxide injection to reduce the pollution of environment. This is the natural gas injection. This is the injection oil. The way water injection we had explained for the steam injection has happened. Now we will be utilizing the gas, and through this the gas will sweep the oil, and this oil production will increase. So this can be a good procedure where the flaring, suppose somewhere the gas consumer is not there, gas is being flared. Instead of gas is to be flared, we can go for natural gas injection, so that it will have the benefit of taking more production from there. And in that way, this gas which will remain in the reservoir for some time till the consumer is tired up, that gas is not being flared. So it will be really good that no hydrocarbon is being lost from the reservoir. Okay. Nitrogen, similarly, like other gases, we can use the nitrogen. From air, we will take the nitrogen. And as we are using nitrogen without oxygen, so definitely no fire will happen. Nitrogen is utilized as a gaseous fluid only to displace the oil and take the more production from the reservoir. So in this case also you need a separate well. Then CO2 or flue gas injection. So suppose if you have got CO2 source, for example, you have thermal power plant, or even the refinery of gas, or many other locations, wherever steel plant, wherever you will find that CO2 is being generated, and like along with the flue gas is being vented, that gas can be captured, and that gas can be, now you see, that can be put into the formation. And if we put it into the formation, then definitely we can expect the same way the viscosity will go down, and the displacement also will take place, and more pressure also will be generated, so more production can be made available. This is the carbon capture and storage. So here you can see that CO2 storage in coal beds, means whatever CO2 is available, which will be collected through pipeline. For example, cement manufacturing, you see, they have got a lot of CO2 which is being vented into the atmosphere. Okay. Now, instead of getting the air pollution because of this CO2, which will have global warming or acid rain, all those things. So now what can be done? It can be either put into the coal bed also. There it can be stored. It can be taken into the saline aquifer, means where the at some depth where the water source is there and that water is not to be utilized for any purpose. You can put that CO2 there also. You can put in oil and gas reservoir. This is our area. So if we put CO2 in our location, means oil and gas formation, then we can increase the oil and gas production from that also. Or we can have CO2 storage bed also, means from here the CO2 will not go to any place. This is simply a rock which can keep the CO2 captured there. Then third is the chemical EOR. The gas is over, the thermal is over, now we can go for chemical. The injection of various chemicals can aid the oil mobility through reduction of surface tension and oil viscosity. So earlier, first one have given the thermal, mainly the viscosity. Second one, gas has given viscosity, sweeping as well as pressure. Third one is giving chemical. It is not increase the reservoir pressure, but only it will reduce the surface tension and oil viscosity. Because this is like soap solution basically. And if we use that, the surface tension will go down and ultimately the resistance will go down, the mobility will increase. Chemical EOR can be done by alkali injection, surfactant injection, polymer injection, and combination of all three. Any two or three, whatever way you may be. Individual also can work, and if you do the combination, you will get the maximum and best result. Alkali injection, you see, this is the injection well of alkali. This is, and what it is doing, you see, injection of alkali or caustic solutions onto the reservoir that has oil with naturally containing organic acid. So the reservoir which has got organic acid, that will be more beneficial if we put alkali. Alkali usually reacts with organic acid to produce soap that can reduce the interfacial surface tension and make the oil mobility move faster toward the production oil. Alkali flooding is not recommended for carbonate reservoirs because of reaction of alkali with calcium ions to form participants which may clog the formation. So alkali only drawback is that in case you find that the field is having carbonate reservoir, in case of sandstone it is always better. In case of limestone it is bad because it has got carbonate. So that time you should avoid using alkali injection. You should go for other chemical like polymer and surfactant. Okay, this is the mechanism what is explained in this diagram. Gradually how more and more see this blue is means oil. So more oil is getting segregated, accumulated near the oil well. Surfactant. This process involves injection of dilute solutions of surfactants or soap. Surfactants usually lowering the interfacial tension or capillary pressure. Special formulation of oil, water, and surfactant microemulsions can be particularly effective in this procedure. Surfactants are usually sensitive to high temperature and high salinity. Mostly used surfactant solutions are petroleum sulfonates, biosurfactant such as rhamnolipids, polyethylene oxide, sodium dedicyl sulfate, and dedicyclamine hydrochloride. These are the usual surfactant which is utilized, and as it is soap solution basically, it will reduce the surface tension or the interfacial tension. Polymer injection, this is having another benefit basically. The polymers usually increase the viscosity of the injected water. Injected water which will be injected, in case it has got some polymer, then the viscosity of this water increases. So it will have more easy sweeping, because as this water has got now additional viscosity because of polymer, that will increase the sweeping of this oil in a better way. And the polymer which we use usually polyacrylamide, salt added polyacrylamide, hydrolyzed polyacrylamide, biological polysaccharide, and xanthan gum. These are the polymer which is being utilized for injection, and this is the producer. So this is the shape. You see what sort of benefit you are likely to get. In case we get this, it is not better. In case we get like this, it is better. So we need to monitor also the reaction of polymer injection, and we should do the logging and see the results, what sort of distribution is happening in the oil movement. And then this is the combination. So this is the combination we need to explain. Okay. Then this is the final procedure. This is called microbial. This process involves the injection of microorganisms and nutrients such as molasses or ammonium nitrate into an oil reservoir, and then shut off the well for an incubation period, allowing the microorganisms to react the oil in reservoir to produce. Means what is happening? If we put some water and nutrients like molasses, then and keep it in the reservoir for some time, a lot of microbial formation or algae formation will be there, and they will ultimately give the benefit what we have got through the other procedures like surfactant, polymers, biomass, whatever gases, whatever benefit we have got in the previous procedures, all those benefits will be available by injecting microbial. So microbial EOR finally will result in wettability alteration, interfacial tension reduction, emulsification, viscosity reduction, reduction of mobility ratio, oil swelling, selective plugging, increased reservoir pressure due to formation of gases, and increase in permeability due to formation of acids. So microbial basically has really very big advantage, but only thing is there are limitations also, because we need to culture the microbial in laboratory for industrial purpose, and that needs a lot of time, a lot of space, and a lot of fine tuning. So that's why, although it has got a lot of benefits, still commercial utilization has not been extended the way it has got for thermal and gas and polymer. As we said, wettability. This is basically the wettability. Wettability means the oil is in touch with rock surface. You see, this is the rock surface. And if it is touching, if the oil is touching all the surface, that means its wettability is more. So if we can reduce that, then you see the oil droplets will happen. So that means it will flow more. So we'll have to reduce the stickiness. This is called wettability. Wettability is basically the tendency of one fluid to spread on or adhere to a solid surface. So it has got some wettability angle basically. So that angle will decide. There are certain angle. We'll explain here also. Interfacial tension. No, that I forgot to put it. Basically, there are
Something like hydrophobic.
something like.
Sir, hydrophobic liquid.
You can say basically if you put the water on glass or mercury on glass, for example, will you get the same size of droplet?
No,
The
sir.
mercury will be spherical, okay, but water will be spread, right?
Yes, sir.
So that is that angle, wettability angle, that is called how much area is being covered by that liquid surface. Okay, so the wettability is dangerous. Means more, for example, if the in case of water, if it is spread on glass, that means more force is required to remove this water from the glass. But if it is like mercury, suppose if the small droplets or spherical, even a small force can move it, right?
Right.
Yes, sir.
Yeah. So that explanation is given here, and that advantage will be getting by reducing the wettability. Interfacial surface tension. Basically, surface tension, you know, that is the surface means air and liquid. Here it is solid and liquid. The solid and liquid. This is the crude oil, for example, and rock. So rock is solid and oil is liquid. So that interfacial tension will be having some interaction if we use these materials like microbial, chemical, whatever we put, like mainly for polymer and soap solution, and microbial will get these results, not for thermal as such or for you can say gas injection, but for these two will be able to change the interfacial tension very rapidly. And emulsification, you see, this is explained in the, these are the stone, okay, and if you do not put the emulsification, oil will be like this. Second, you see, you have put some emulsification. Third, if it is more, then you see it has got separated out. So more oil, easy flow of oil will be there. So these things, I mean, they are simple to understand from the picture, but practically all of them are happening in the reservoir. We cannot see them, those actions. They are all laboratory tested. That's why we can explain. But all these activity which are happening to drag the oil flow or to take more force for oil to flow, that gets reduced because of such action. The viscosity we have already explained. If the viscosity is reduced, obviously the mobility will increase and more easy flow will be there. Mobility ratio is the movement of oil and movement of water. So if we make the ratio, you see, this is the equation. So if we get better mobility ratio, I mean more, that means more water flow will be there. If we get less, more oil flow will be there. So we will have to selectively choose basically what actions is being happening because of such your methods. Oil swelling, we had explained in other water injection case also. In case the swelling is there, the cell swelling, then it will obstruct the pore. I mean, it will increase the rock quantum and reduce the pore. So that's why that will plug. Here, in case oil is swelled, means in case the oil is expanded, again the same problem will be there because more oil cannot now easily flow. So that oil swelling also is an important parameter which is to be measured and which is possible to be achieved through this procedure. Then selective plugging, this we have clarified through water injection oil also, how we can go for selective plugging so that wherever it is not required, we can plug them and we can reopen them also. It depends on, I mean, the very continuous monitoring what is happening in the reservoir. In case of your principle, another 5 minutes only, okay. In case of principle, basically we have got two, this is a multiplication theorem basically. You see all the procedures are having multiplication theorem, means either displacement or volumetric sweeping. The volumetric sweeping is aerial and vertical, then the volume, and displacement is total movement. So benefit of or multiplication of both will be always the maximum. So this is explaining basically how we are able to get the displacement efficiency, how we are able to get the aerial efficiency, how we are getting the vertical efficiency. And if we get all of them together, then definitely our percentage recovery efficiency will be more. This is the equation. The RE is equal to D, A, and E. Then cost of UR. So when we are taking up some UR method for taking additional production, so definitely the question will come how much financial burden is there for every procedure. You see, this is in case of water flooding, the cost is very, see this is the cost, vertically the cost, horizontal is the recovery. So vertical less means more benefit is there. So water flooding, as you had explained for water flooding in case of water injection, we have got a lot of products benefit. Then surfactant if we utilize basically the soap solution sort of thing, then we have to go for more and more investment basically because they are all costly chemicals from consumption point of view. Because it's not that the unit cost is to be seen just by appearance. It has to be seen from the quantum which is required. As more and more quantum of surfactant is required, so the overall cost will be very high. And at the same time, we can get recovery also even more than what we can get from water injection or CO2. So surfactant in that way will be always better and even best also we can say. In case we can invest more, then we'll get more and more oil also from that. And microbial, as we say lastly, that this is not commercially that much popular, although it has got benefit. You see how much benefit is there. It can go up to 65% recovery also, and cost is very less. The only thing is its availability is very limited. This is the global UR production. You see, in case UR is not there, definitely the oil production will go down. So this is the UR quantum which will add up the production with time. And in India, we have got the UR benefit around 2.2%. And worldwide, if you see, the thermal is maximum, then chemical, then hydrocarbon gas, and then CO2. So this is the overall global picture. They are all the company who are working for UR, Saudi Arab, PetroChina, ExxonMobil, Chevron, Royal Dutch Shell, Kane Energy, Plain West Energy, Statoil, Patamina, Sino, Vico, Petrosalat, Total EP, BP, Shell. They are all working for GOR. And these are the places you can say. where we have put thermal, all those descriptions are given. This is the CCS scenario. As we have explained that CO2 also is to be required to be sequestered. So we have got a map also where this action has already been started. In India, we have not started, as you can say right now. You are in India, ONGC has already started in Gujarat, and Ken Energy or the Vedanta Energy has also started in Rajasthan. So the Rajasthan, in fact, going in a very full swing for commercialization, but ONGC is still in the experimental stage in many locations. Commercialization with gas injection is there, but with other like combustion, like thermal, like CO2, all those things are yet to take place in a big way. These are the factors basically. What are the factors to choose? And you see, all the challenges can be solutions also. We have given the description in this. And this is the life cycle UR, means if we plan for UR, it will take these many steps, and almost 6 to 7 years time will be required to get the real benefit for UR. So to conclude here, enhanced oil recovery is also known as tertiary recovery, which targets immobile oil in mature reservoir to increase flow. UR are usually conducted through thermal, gas injection, chemical injection, or microbial. The growing demand of crude oil necessitates the UR application irrespective of its cost. However, good sign is that crude price is increasing and therefore boosting UR. As production from mature fields in India is in decline, companies are now looking to implement UR technology to boost domestic production. ONGC has spent enough time in onshore pilot UR. Now time has come to look for commercial applications. Ken India has finalized polymer flood in Mongla field, and with encouraging results, they are considering a field-wide application of the technique. Ultimate oil recovery lead to increase the recovery to 60 to 70, even 80%. Still, some percentages are left, leaving enough space to the next generation to take it further to 100%. So, whatever has been so far finalized to the technology developed, that can still not be sufficient to take it to 100%. New generation means new generation still can work on that. How the total oil in place can be basically extracted from any existing oil. That's all. I have finished. Yeah. Okay. Any question quickly? You can.
Sir, is UR all techniques are necessary?
UR
I think it's sir very much cost taking, sir.
Yeah. You're very correct. As we have seen or we have explained also, in India, it is only 2.1% coming from UR. Whatever total products UR production has happened worldwide, India's contribution is only 2.1%. That is because you have understood that UR has definitely have a lot of investment requirement. So Middle East also was not very much thinking for taking more production through UR. Instead, they are thinking to go for new oils to be developed. So that psychology and that calculation is always there. And as now the oil price is little more and going to be further more, so that's why your technology may be popular. Otherwise, your is not today's technology. All this technology have developed from 1980s onwards. But their commercializations are not popular because of investment aspect, that what you had explained right now. So it is not essential whether you will go for new oil well or you will go for implementation of UR in that mature field. That depends on money, and of course more and more success only will finally dictate whether you should continue or not. But they are all commercially beneficial as of now, but not popularized from the investment point of view. Okay.
Right, sir.
Thank you, Prashant Induda, for such a wonderful presentation.
Yes, sir.
Do you have any more to discuss further? Actually,
Sir, I have another question, sir. A small question.
Yeah.
Sir, you have told earlier that Mumbai High is placed in 1978, and any platform can stay stable to, up to 20 to 30 years. So, is the time come to close Mumbai High?
No. Actually, you see, initially when we are actually whenever any offshore area or even in onshore area, we have to plan for any new field to be developed. Definitely, we have to consider the RYP ratio that we said, no, the total reserve and total production rate.
Yes.
So RYP usually will take 25 years because we understand that what you said, that the stability of the platform, the structural, all those aspects cannot be taken care beyond that period. But if you go for the prevention methods, there are many prevention technology that if you take, definitely you can sustain even for some more years. And that is what is being taken up because they are all world-class basically structures. All the offshore structures everywhere, in fact, not only in India, everywhere, they are all world-class. Means they need more and more concentration from the beginning itself so that it does not get damaged. So as all those things, that is, we have got IMR section basically, inspection, maintenance and repair. All this marine growth, which is there across this structure, the template, whatever you have seen, no. So all those things are cleaned and cleared every frequently. I mean, there is no problem coming from those actions. In fact, we'll have a lecture on the last day also, asset integrity. There we'll explain about how we can increase the offshore stability also. Okay.
Thank you, Ashwinendra. Actually, today we are having another program.
So
which will be just now live streamed from this particular channel. This is on our Janmashtami program. So I request all to participate if you are interested. That is there. That is available in our YouTube channel. And like that, so we wish to close the session just now.
Okay.
Participants,
if you have any question
sir,
also, I will be there. I think Friday again I will be talking, sir.
Yes, surely.
Yeah, Friday of course we will have again two different topic, but we can take up regarding this topic also some more questions if it comes in between also. You can ask me on that day. Okay.
Okay. Thank you, sir.
Thank you, sir. Thank you.
We are closing this session. Okay.
Yes, sir.